Hello, this is Professor Salahat, and in this video we will continue with the homework, and we'll look at number 22, homework 6, chapter 7, number 22. And in this problem it says the research center claims that 30% of adults in a certain county travel or would travel into space on a commercial flight if they could afford it. So let's stop in here. And in here, I can really come with those two statements. Again, the problem is talking about 30%. It's talking about a percent. It's talking about a proportion. They didn't say a mean, they said 30%. It's a proportion. And again, the claim, the research center claims that 30%. They didn't say less than 30%. They didn't say more than 30%. They didn't say different than 30%. They said 30% means is 30%. And that is our claim. Actually, it is their claim. So we continue. The opposite of equal is not equal, and it's 30% as before. So those are the H note and HA. So in here, to respond to this claim, a random sample, so there is N equal to 1,200 adults in that country were surveyed, and 33% say, so the proportion P hat is 0.33. Notice from here, I can multiply the 0.33 by 1,200, and that will give me the number of people who said yes. So if we multiply 0.33 times 1,200, that's going to give us a total of 396. So there are 396 who said yes. 396 or 33% say they would travel into space on a commercial flight if they can afford it. And the question in here is giving us alpha equal to 0.01, which is that confidence or significance level. So the question in here says, is there enough or sufficient evidence to reject the claim? So we'll try to get there by answering the following questions in here. The first one is identify the claim. Notice that the claim is the is. So the is the last one. Last one, it says 30%. Notice I'm putting 30 because it says percent after that. If there is no percent, I would just put 0.3. 30% of adults in the country would travel into space on a commercial flight if they could afford it. Now, I did not choose A, B, or C because in A it says no more than, in B it says at least, and in C it says not. So we are talking about 30%, so we're going to go there. The next part of the question will be identify H note and HA. So let me shrink this a little bit. And now when it says H note and HA, the problem will be equal, not equal. So we are at F. And in both, now notice that there is no percent written. So I'm going to put 0.30. And again, the top and bottom will be 0.30. So we check this answer and we go to the second or the part after that. And in here it says, use technology to find the p-value and identify the standardized test statistic. So in this case, we're going to use technology to find both the p-value and the test statistic. And how we do that, let me just go in here. How we do that is we go to stat and we're going to go to calculators. And we're going to, I'm sorry, we're not going to try to find the critical, sorry. We're going to go to proportion stat here. One sample, and then with summary. And after that, we're going to put number of successes, which is equal to the number of yeses, which is 396, and number of observations, which is the same as the number n, which is in this case 1,200. And we're going to fill the test as we did it before, and we hit compute. So let me just go through those steps. I'm going to go to stat, proportion stat, one sample with summary. Then it says what's the number of successes, which is 396. What is number of observations, which is n, 1200. And we look at the test and try to match the test from what we have here. It is equal, not equal, and it's going to be 0.30. So it's going to be in both 0.30. So the test is matching 100%. We hit compute. And let me move this in here. And we're going to try to answer. So what is the Z statistic? Remember, they didn't say what is the Z critical, but they said the standardized test statistic. So the Z statistic is this, which is 2 point, and we need only two places, going to be 2.27. 2.27. And the next part of the problem, it says, what's the p-value? The p-value is also given here, which is point. And again, they want 3 decimal places. It's going to be 0.023. Answer. And finally, we need to make a decision. So let me just put this down and come to the decision stage of the problem. Now, how we make a decision. Now, we have a rule to make a decision. And the rule is we're going to look at the p-value. And we're going to look at alpha. Alpha in the problem is 0.01. And the p-value in the problem is 0.023. Notice that the p-value is bigger than alpha. In this case, we fail to reject H0. Every time the p-value is greater than alpha, we fail to reject H0. So our decision is not to reject H0. Let's go up here. Here's our problem. And in this case, let me make this smaller a little bit. Smaller more. We're going to fail to reject H0. By not rejecting H0, notice that you are not rejecting the claim. So the decision not to reject H0 is going to translate into not rejecting the claim, because H0 is happen to be the claim in this example. So decide what to do in here. So it talks about the null hypothesis with H0. Fail to reject the null hypothesis, fail to reject H0. And if you fail to reject H0, what happens? You can say there is or is not enough evidence to support the researcher's claim. Notice, and again, I keep talking about this, when you fail to reject a claim, the reason we fail to reject a claim is not because the claim is true, because we don't have enough evidence to do otherwise. So in this case, there is not enough evidence to reject the. Again, if you fail to reject, then there is not enough evidence to reject. Somebody can say, listen, let's just use the other one, which is there is enough evidence to support. Because if you are not rejecting, you are supporting. Both statements would work. But in this case, I think if you check this one in here, it's going to give you the wrong answer because, and I mentioned this before, because there is enough evidence to support. Notice in statistics, we are not in the business of supporting. We are in the business of finding a problem. So it is more appropriate to say this, to say there is not enough evidence to reject. Now, if you are failing to reject because you don't have enough evidence to reject, like in court, if you fail to convict, it's not because there is enough evidence to acquit. No, because there is not enough evidence to convict. So in this case, this will be the correct answer. So notice the difference between the two statements there. Now, let's move to the one after, which is number 23. In number 23, it says in here, for students who first enrolled in two-year public institutions in a recent year, the proportion. So this is really a proportion problem. So we're going to talk about H0 and HA. And both of them are talking about a proportion. So we can really come in here and say this is a proportion. So this is a P, and that's also a P. So the proportion, let me go back to the problem, who earned a bachelor's degree within 6 years was, so the proportion was this number. So this is like a claim. The claim is the proportion was is the same as is. So it's gonna, again, we're gonna go in here and we're gonna put is or was 0.387, 0.387. And again, because one is equal, the other one will not be equal. Now, so again, we're gonna come in here and say the top is equal, the bottom is not equal, and it's gonna be for both 0.378 or 387, sorry. 387, let me double check, yes, 387. So that is, it's, okay. Okay, I see, and I hope you see the problem. I think I rushed in here to read the problem. Now, actually, here's, let's see this. For a certain institution, this is not the claim. Let's start in here. It says in here, and I rushed into my problem here. Let's see. It says in here, the president of a certain college believes that the proportion, believes the same as claims, that the proportion of students who enroll in her institution have a higher completion, higher. So sorry about this, because at first I didn't read the full problem, which is a mistake. I should not do that. It says higher. Higher means greater than, and a greater than goes with the lower part. And the opposite of higher is less than or equal. So we have to come back in here. And we, by the way, we don't have choice for the top one, but to put equal. Because again, I cannot put less, I cannot put not equal or greater than. The top has to have an equal in it. And the only equal possible is equal. But the bottom one has to be greater than. So that is because the president here believes it's higher. Higher means greater. So we have to be careful from now on, is that we have to read the full problem completely. Now, which of the following is a type 1 error? Notice that type 1 error, we talked about this. Assume H note, type error, talks like this. Assume H note is true and we reject it. In this case, let's assume that, okay, the proportion is lower or equal and we reject it. So we're going to assume this is true and we go and reject it. So type 1 error is the president rejects the hypothesis that the proportion of students, let's see what the options are. The president rejects the hypothesis that the proportion of students who earn a bachelor's degree within 6 years is, okay, 0.873, whatever, when in fact the proportion is greater than, okay? Now, remember, we're looking for when in fact the proportion is less than or equal. In fact means when the reality is, when the truth is. So it's not going to be the A. When in fact, look at the part B. When in fact when in fact the proportion is greater than, we're not going to look at greater than. We're looking at the fact which is the truth. The proportion is, okay? And the last one, when the fact the proportion is. So we are between C and D. Between C and D, because the fact it says is, look at this, equal. So we're looking at equal. When fact H note is true, so this is the fact. H note is true, and what is happening in here? We're rejecting the truth. So the president rejects the hypothesis that the proportion within 6 is, and look at D, it says the president fails to reject. We said in here, type 1 error is to reject something that is true. So it has to be part C. Part C is, the truth is, the proportion is 0.387, and the president goes there and rejects it. So that is type 1 error. Now, what is type 2 error? Type 2 error is when H note is false. What do we mean by H note is false? Now, notice that H note said equal. So when equal is false means when the proportion is not. When it's false, this means is not. Okay, and then the president what? When H note is false and we do not, or the president does not rejected. H naught. Okay? So, which one is that? The president rejects the hypothesis. Okay? The president rejects the hypothesis that the proportion of students who earn bachelor's degree within 6 years is, remember, the president rejects. We said when H naught is false and the president does not reject. That's what we're saying. The president did not reject. Type 2 error is not rejecting. And in the first one, it says rejecting. In the second one, it says the president fails to reject. The third one, it says the president rejects. And the fourth one, it says the president failed to reject. So we're talking about it's either B or AD. So let's read B. The president fails to reject the hypothesis that the claim of a proportion of students within is, okay, when in fact the proportion is true. Okay? Now, and here it says the president fails to reject the hypothesis that the proportion is when in fact it is greater than. Okay? So in this case, we're going to choose either B or D. And in this case, remember, type 2 error is fail to reject H naught when it's false. So let me go back in here. Here is H naught. H naught is P equal to 0.387. And HA is P is not equal to 0.387. So what we are saying in here, we are saying this is false. Now, when H naught is false and the president fails to reject it. So the president, let's read part C. The president rejects the hypothesis, I'm sorry, here, part B. The president fails to reject the hypothesis that the proportion is, so the president fails to reject this one, when in fact it is what? The proportion is 0.3 something. We said when it's false, so we have to go is not. So that is D. Okay? Because if it is 0.387, then it is true. We are saying it's not. So this is the true one. But the president fails to reject the top one. Let's go to the next one. If a hypothesis is tested at alpha equal to 0.05 level of significance, what's the probability of making type 1 error? Now, again, that is really the definition in number 24. What is the definition of alpha? Alpha is the same as the probability of making type 1 error. So if a hypothesis is tested at alpha equal to 0.05 level of significance, what is the probability of making type 1 error? It is the same as alpha. So the probability of making type 1 error is the 0.05. Okay. Now that's the meaning. That's the definition. We don't have to go beyond that. Now here, number 25, it says determine if the following statement is true or false when testing a hypothesis using the p-value approach. If the p-value, again, so let's go in here. In number 25, it says if the p-value is large, if the p-value, here's the p-value, and here's alpha. It says, by the way, is large. Large means large with respect to what? Always we look at large with respect to alpha. So when it is large with respect to alpha. So if it is greater than alpha, what happened? If the p-value greater than alpha, we fail to reject H naught. That's the rule, always. So in this case, now reject the null hypothesis. And here they tell you, reject. And we are saying here, no, fail to reject. So this statement is false. Because this statement should be, if the p-value is large, don't reject, fail to reject the null hypothesis. Number 26. In number 26 in here, let me get the marker. It says in here, we have the following. We gave you H naught, which is P equal to 0.45. We gave you H1. By the way, they call it H1. It's the same as HA. So 1 and A is the same thing. So H1, it's the same as HA. P is less than 0.45. Okay, and they give us N equal 150. They give us X equal to 62. By the way, this is the number of yeses. They didn't give me a proportion. They gave me the number. And alpha equal to 0.05. And in this case, they asked me to find the p-value. So to find the p-value, I go through StatCrunch. Oops. And let me move this to the side. This way we can see everything in here. Or I can still look in this. It doesn't matter. Here we go to stat. Again, this is a proportion problem. One sample with summary. They gave me the number of successes, which is X, which is 62. And they gave me the number of observations, which is, in this case, 150. And they told me the test is P is equal to 0.45. And P is less than 0.45. So I'm going to choose the less. When I do everything in here, what is the p-value? The p-value is going to be here in this table, which is 0.18. And they want us in here just to go, actually they want everything, 0.1834. When I put those numbers in, that's the p-value. The next step in the problem in here, it says, okay, so what should we do? Notice again, as in 25, this is exactly the same rule. We're going to look at the p-value, and we're going to look at alpha. Alpha in the problem is 0.05. P-value is 0.1834. So if the p-value is bigger than alpha, in this case is bigger than alpha, fail to reject H note. So we're going to fail to reject H note. Since the p-value is bigger than alpha, do not reject the null hypothesis. It's part B. Okay? So that is what we do. Next question. Number 27. In number 27, for the following hypothesis test, determine the null an alternative hypothesis. Also classify the hypothesis test as two-tail, left tail, or one tail. So let's read the problem, and I'm going to read the problem here. So this is our problem, and we try to go with that problem and try to fill in what we need. Now, the mean length of imprisonment of or for motor vehicle thefts or theft offenders in this country is 15.3 months. A hypothesis test is to be performed to determine whether the mean length of imprisonment of motor vehicle theft offenders in this city differs from the national mean of 15.3. Again, as you see in here, I read the full problem. I learned from my previous problem. Okay, so look at this. And in here, it says the mean. So both H note and HA, they are talking about the mean. So it's a mu. They tell us the mean is 15.3 months. But in here, a hypothesis test is to be performed to determine whether, the mean for imprisonment in this city. So we are testing the claim that in this city is what? This city is or differs. Differs means not equal. So not equal goes in here and equal goes in there. So differs than the 15.3. So this is H note and HA, equal, not equal, and that will lead me to part E. And notice that I'm going to write the word claim in here because they talk about this city differs. So I'm testing the claim that this city differs. Now, the question is this right tail or left tail or two tail? Notice that because of not equal, there are two tails. So there is a tail in here and a tail in there. So this is a two tail problem. Again, how we know it's two tail? You always look at HA. If it's less, it's one tail and it's left. If it's more, it's one tail and it's right. If it's not equal, it's two tails. Now let's go to the one. last one in here. And again, I want you to ignore the table in here. Those tables are if you want to do the problem by hand. We're not going to do anything by hand. Here it says determine the critical value for a one mean z-test. Okay, one mean z-test. And in this case, let me draw a picture in here to start with, and this is number 28. The problem says you have a two-tail test. So they're telling us it's a two-tail. So this is a left tail, this is a right tail. And they want us to find the z critical. Notice that you'll have two z criticals, not one, because of two tails. And they tell us that alpha equal to 0.04. Now to find the critical values, we, again, z critical, we're going to go to stat, calculators, and we're going to go to normal because we're talking about z. And then after that, we leave the mean and a standard deviation alone. We go to last box, and I forgot to do something in here. I have to choose between. I choose between because we have two tails. So, and go to the last box, and in the last box, put 1 minus alpha. That is if you have two tails. If you have one tail, don't use between, just put one, don't put 1 minus alpha, just alpha in the last box. So let's go in here and try to do this problem. I'm going to move this in here. Now I'm going to close this. I'm going to go to stat. I'm going to go calculators. I'm going to go to normal. And I'm going to choose between because two-tail test. And in the last box, I'm going to type 1 minus alpha. In this case, alpha is 0.04. I just put 0.04 in there. So it's going to be 1 minus 0.04. And that will give me the answer I'm looking for. So the question is, what is the critical value? Actually, there are two of them. One is -2 point. And again, they want me to go two decimal places. So it's going to be 0.5 and put a comma because they say use a comma and 2.05. So one is negative, one is positive. And when we check the answer, it's going to give us the correct answer. Now, the question after that, which one is the picture? Look at this. The first one, A is left, the C is right, and B is two tails. So we're going to choose the two tail. That is the answer. And this way, we finish the homework. I'm going to stop in here, and we will meet at another video for another subject.